My name is Mark Lois. I am a trainer for Shearer Supply. And today we are going to be talking about the new 17 SEER multi-speed air conditioner and heat pump. Where this is an introduction course of the new product, how it works, how it thinks. There is not certification required for this unit. It is not a communicating piece of equipment. So you do not have to have a certification to purchase and install it. This is more of an introductory class to let you know how it works and such. So some logistics for today's class. The class is being recorded. So we will have it out on YouTube, hopefully sooner than later, so that if you want to share it with somebody else or you've missed part of it, you can finish it at another time. We are going to go straight through the class without a break. I'm guessing somewhere around the hour 15 mark is what it's going to take us to go through it, depending on the questions and such. But let's get started. The agenda will talk about nomenclature, application, installation, startup, and some troubleshooting on the board. This is an inverter-driven multi-stage unit. It is a 24-volt operated unit that will take a call from a Y1 and Y2, very similar to the unloading compressor. So we'll have 70% capacity with a Y1, 100% capacity with a Y2. It will match with your normal R454 cased coils. It'll also match with the 5TEM6, the 5TEMC, the 5TAM5, and then the 5TAMX as well. Operates with similar speeds as the two-step scroll compressor. Matter of fact, operation-wise and setup-wise is going to work very similar to our old two-stage unloading compressor. Model numbers for the heat pumps, we have a 5A 6H7. So 5 meaning the new refrigerant, 6H meaning it's a heat pump, 7 for 17 SEER. Now, a lot of these matchups do go over 17 SEER with this product, and hence the reason for the 7 in the model number. The straight cool units are a 5A 7A7. So 5 meaning R454 refrigerant, 7 meaning is a straight cool, and then 7 following is the 17 SEER of it. The benefits of an inverter-driven product, right? The biggest one, obviously, is the lock rotor amp at startup. So if you have an application where your wire size isn't right, or you've got a long wire run, where you may see the dimming of lights on a compressor startup, the inverter product won't do that. It's a soft rolling start for the compressor, so you don't have that massive lock rotor amp on startup. And if you have a homeowner that's using a generator for backup, we don't need the big sizing of that generator to start this unit. We have a little more capacity with the heating. We'll talk about that and more with the heating and the cooling, depending on outdoor ambient. We'll get into that a little bit more. Also, at mild conditions, it'll change compressor speed just a little bit to save it some efficiency. And with the inverter compressor, we can also speed up that compressor and lower outdoor temperatures for heat pump operation to maintain that capacity. Matchups. We've got a lot of matchups with this new 17 SEER unit. So on the, we can actually do a straight condenser and coil with somebody else's indoor unit. Now that'll obviously drop your efficiency rating. And when I was looking at AHRI yesterday afternoon, these were in the 15 and 16 SEER range when you're only doing the coil and the condenser with a non-AHRI matched up indoor unit. Now, with the air handlers, we have the 5TEM6, which is our new refrigerant TEM6. It actually installs and operates like the old TEM6, except it has the mitigation board on it. So this is a true variable speed indoor air handler. And then we've got the new 5TEMC, which is actually our link air handler, but it also works in 24-volt operation. So the 5TEMC is just a little higher enhanced capacity in the coil. Air handler matchup as well that you can use it. Now, just make it perfectly clear, when you're doing the 5TEMC or even the 5TAMX, you're going to be operating that air handler in 24-volt operation. So it's a 24 operating air handler at that point. On the gas systems, we can actually match this up with our base series S8X1 furnace. So that single stage gas furnace with a constant torque indoor fan does have the capability to be set up for 2 fan speeds. And you can actually fine tune those fan speeds with the 9-speed constant torque fan that's inside that unit. And very similar to the S9X1 as well. So if you need a 90% single stage indoor unit, these units actually do rate with them, and they do rate over 17 SEER. What you do lose with the S8X and the S9X is you lose the ability for the enhanced dehumidification that BK terminal will help control. Now, if you want that enhanced dehumidification, you would use the S8V2 and the S9V2 furnace, where you can use the enhanced dehumidification with the American Standard 824 or 724 stat. All of those matchups do go over 17 SEER. Design criteria, operating range for the cooling is 55 to 115. Operating range for the heat pump is from 0 to 66 degrees. Now, this is not, again, a low ambient system. So if you've got somebody that is wanting to run their air conditioning in the middle of winter, this is not going to be a unit you're going to want to do that with. This unit will actually lock itself out at 32 degrees outside for any cooling call. So it's not going to operate below 32 degrees outside for a cooling call. Physical dimensions, there's really 2 footprints for the unit. The 2-ton and 3-ton are 41 by 30 by 33. That's 41 inches high. It is 30 inches in depth and 33 in width. And then the large footprint, which is your 4 and 5-ton, is 41 inches high, 34 by 37 inch base. So 2 dimensions for 1 dimensions for the 2 and 3-ton, both straight cool and heat pump, and then a larger dimension for the 4-ton and 5-ton. Same cabinet for heat pump or cooling. Refrigerant piping. This unit pipes very similar to a single stage product. So you've got your maximum line lengths of 150 feet, vertical distance of 50 feet. So even with our new variable speed product, a lot of those line lengths have changed. They've gotten shorter. But with this new single or 24 volt inverter product, we can still go to our typical line lengths of 150 feet. Now, the unit is rated with a 5/16 liquid line and is shipped with a 5/16 liquid line, and 3/4 on the suction of the smaller sizes and 7/8 on the larger sizes. But it is approved with 3/8 line sets as well. As a matter of fact, if you have an existing 3/8 line set on the liquid size, your lengths and stuff don't even change with that. You're still able to use those 3/8 sizes to do that. So this is on the 2 and 3-ton. You can see that you can use a 1/2 inch, 5/8 or 3/4 inch suction line, and either a 5/16 or 3/8 liquid line on it. On the 4-ton unit, you can use 5/8, 3/4 or 7/8 on the suction line, and then 3/8 or 5/16 on the liquid line. On the 5-ton, you've got 5/8, 3/4, 7/8 on the vapor line, and then on the liquid line, you can use 3/8 or 5/16. If you ever have questions about line set sizing, American Standard has actually added this to their AS Dealer Net, which is American Standard's website for you as the contractor to get your marketing literature, your drawings, if you wanted spec sheets. This is the same place that you would go for all that stuff. There is a tab on the top page when you open it up that says tech support. That tech support is going to open another page, and the very first thing that'll pop up on that page is the refrigerant piping program. Inside that refrigerant piping program, the first screen that's actually going to populate is the job or system page. Most people aren't going to use or fill in any data for that. That's your homeowner's information and address if you wanted to make a printed report. But if you look at the left side of the tab, you'll see installation. That's where most people are going to start. Click on the installation tab, and then it's going to ask you about system design. This has been available on American Standard's website, AS Dealer Net, for about 7 or 8 months now. So you have the ability to actually go backwards if you wanted to do an R410 system to make sure that you had the proper line size, or even with the new R454 system, this will help you to decide if that line set will work. And even if you're doing new construction or you're doing a line set, it's going to show you the best design line set for that system by filling this out. So what you would start with is in the first tab on the left-hand side is the unit information. You're going to select if it's a heat pump or straight cool, what series of family it's from, and then the actual model number of the unit that you want to use in that application. You go to the next tab, which says installation information. You're actually going to select if the unit's above or below outside where the indoor unit is. Then what you're going to do is put total line set length. You're going to input the vertical distance, right? What's the height that it goes up or goes down to the unit? How many elbows are being used in the unit? And then hit calculate. Once you hit calculate, it's actually going to give you the recommended size in that option 1 sizing. That's the recommendation. So if you're doing a new line set, you're doing new construction, or you're going to make a new line set, this will tell you which one you can use for optimal operation of that system. Now, I know in most of your applications, right, you're doing a change out and the line set exists. So after you've let it calculate the recommended sizing, you can actually go to that 4th box to the right where it says option 2 sizing. In that box, you can see there's a drop-down arrow for both the liquid and vapor line. You can actually select the lines that are actually existing in the home. Once you select those, it'll tell you how that system's going to operate. Now, here's the key component. If you go to the drop box and that size piping is not available, that means American Standard does not want you to use it. So if you click on that box and you have 1 1/8" suction line, and 1 1/8" is not an option inside that box, American Standard is telling you that you need to change that line set. But this is available to you 24 hours a day, 7 days a week, right from your smartphone or tablet, that you can actually do line set sizing right out on the job, when you're standing in front of it. Installation wise, if you haven't been through one of my A2L classes yet, this may be new to you, but with the new A2L refrigerant, the recommendation from American Standard is when you're installing a new system, they want a 600 PSI nitrogen test on the refrigerant piping and the indoor evaporator coil, 600 PSI for 1 hour. That's the recommendation from American Standard. Now, if you're also going to say did a service repair on the condenser as well, so you're going to do a pressure test with the condenser, line set, and evaporator, that pressure now drops to 450 PSI. It's not because the condenser coil won't handle it. It's because the compressor manufacturer does not want 600 PSI going through the compressor itself. You could separate the plates inside the compressor and cause damage to it. And just as a little pause here, I'm going to jump into the Q&A and see what's in there. The only thing that is available for you guys on your side is the Q&A section. So if you do have a question, drop it in there and I'll kind of take some breaks during where we can address them. So let's see what's in there now. Will the BK jumper be needed on any of these indoor units? My recommendation is if you're using one of the true variable speed units from American Standard, where let's say it's the 5TEM6, the 5TEMC air handler, or even the 5TAMX air handler, or if you're using the S8V2 or the S9V2, those are true variable speed indoor fans. My recommendation, and again, that's how you sell the job and what you're promoting to the homeowner, my recommendation is to use an American Standard 724 or 824 stat, which gives you enhanced dehumidification. In that case, yes, you would be cutting that jumper. So if you're using an 824 or a 724 with a true variable speed indoor unit, then my recommendation is yes, to cut that jumper and use the enhanced dehumidification. Is the piping sizing chart available without login to AS DealerNet? No, you have to have a login to access the piping program in AS DealerNet. Actually, any of the programs in AS DealerNet, you do need a login for it. If you're an American Standard dealer, that should be available to you, and your TM can help you get a login for it. Even if you're an employee, not the primary of the company, they can make a login for you as well. There's an administrator within your organization, your own company, that can make a login for you. They just need an email address to create that login. Does the Freon line piping program tell you how much Freon to add? It does not. But in the installation guide, it will tell you how many ounces per foot of liquid line. So if you're using a 5/16 liquid line, if my memory served me right, it's about 0.47 ounces and then like 0.6 ounces for 3/8. But confirm that in the paperwork. It stated that the system does not support advanced dehumidification, but will program it as such. So the S8X furnace is a constant torque motor, and the S9X furnace is a constant torque motor. So they don't have BK availability to it. So you're going to have 2 indoor fan speeds that you can set up, but they are going to be fixed fan speeds at whatever airflow you set up for them. So hopefully that answers your question, Jordan. Let's get back to the presentation. Also, with the recommendation from American Standard, when you're doing a 600 PSI nitrogen test on the system, they're also recommending that you pull that system down to 350 microns. The whole purpose of the 600 PSI test and the 350 micron pull is to make sure that you don't have leaks in your system. Low voltage wiring. So first thing, if you've ever installed our 2-stage unloading compressor, this wires exactly the same. The wiring practices from the 2-stage unloading compressor and this unit wire exactly the same. So let's get into a little bit of detail. Now, this drawing is for a furnace application. Now, this furnace application does show you if you have the BK option, it's showing you that as well. But this wiring diagram will be found in the condensing unit of that system to show you how to wire it off. It wires traditionally like a 2-stage system. Now, if you're going to do dual fuel, you may want to get yourself a control that has outdoor sensing capability, outdoor temperature sensing capability, so that you may have a turnover point for that unit. Now, it will go cooler in temperatures and still maintain capacity, but you're still going to want to find out what that break point is so that you can bring on the supplemental heat with it by possibly using a thermostat with an outdoor sensor on it. The air handlers also, right? If you've installed a TEM6 in the past, which is our true variable speed air handler, and you're doing it with a 2-stage unloading compressor, this wires exactly the same way. And when I say that, what I want to make sure that I point out, if you're a link and variable speed customer as well, you know that we don't need the 24-volt power out to the condenser on our communicating product. But on this 24-volt unit, we must have R and common going out to the unit. It is not an option. The outdoor board does not provide that 24-volt output outside. So you must run the R and 24-volt common to your outdoor unit along with your functionality wires. Now, can you run it with a single-stage cooling thermostat? You certainly can. It'll just run, your first call of capacity is going to be that 100% capacity. Can you still do it if you want someone that wants the inverter technology? You certainly can. So if you're short a wire out there and you just want to run it on single stage, you can. But keep in mind, you will have to have the R and B going to the outdoor unit for it to operate. System charging. You're charging the unit just like you would before to subcooling. Now, to check subcooling on any of our units, I don't care what unit it is, if it's even our communicating or our single stage product, we need it to be above 55 degrees outside to be able to charge in subcooling mode in cooling. We also need the indoor temperature between 70 and 80 degrees, right? We can't have that TXV wide open because your indoor temperature is 85 degrees and expect to set that subcooling. If you are outside of those parameters, the only other way of charging is to weigh it in the system. And actually, it looks like I was wrong on my charger per foot. So if you look at the box here, my charger per foot on 3/8 is 0.47 ounces per foot, and on 5/16 is 0.3 ounces per foot. And that is in the installation guide if you don't remember it later, but apparently I forgot myself. So there you go. There's the adder for it. So if you're outside of 55 degrees to 120 outdoor, and your indoor is from 70 to 80 outside of that range, you're going to have to weigh it in and return to that job when it's in normal operating range and check your subcooling at that point. Now, this is an inverter system. So if you've installed our 17 SEER unit in the past, our old communicating one, or if you even did one of the side discharge units, this is a two-piece indoor inverter, or excuse me, outdoor inverter, two-piece outdoor inverter. The board on top did change itself. Now, this is a 24-volt board that's now on the top of that control. It is actually a two-piece board. We're going to warranty it as one piece. So you're going to change both pieces for a while, and then they're going to separate the warranty down the road that you can change them independently. But right now, it is a two-piece board, but if you have one of the components fail, they're going to replace both of them for you for the near future. And just taking a little tour around the board, starting on the top left-hand side, that's our low voltage connection, right? You can see your typical X for your backup heat, your O for your switchover valve, Y1, Y2, again, ground and R. We do need to power the outdoor board with 24 volts from our indoor unit. The plug for the personality module, the program port, which is actually done at the factory, you won't be using that. If you want to test defrost, there's a force defrost button on the board. The termination point, I'll show you here. You can cut that termination point and raise the temperature of your outdoor defrost. You've got a data port on there. We won't be using that. We have the AOC MOC interface. That's a plug harness from your AOC board to your MOC board. That's just a little jumper wire from one board to the other. Working our way across the bottom, we have our coil temperature sensor, our discharge compressor sensor, and then our ambient sensor. And then coming around to the two boxes with the arrows in it, those are 7-segment LEDs, which will tell you the mode of operation it's in, and will also help you with fault detection on it. Now, it does have a plug for the EEV, but our heat pump units on 17 SEER 24 volt, there is no EEV, so you'll not see anything plugged into that. We're using a traditional TXV on these units, so there'll be nothing in that receptacle. Right above that is our latching switchover valve. This is the same style switchover valve that our inverter board uses, where it just sends a quick pulse to move that switchover valve, and then that voltage goes away. Our low pressure cutout on this unit opens at 20 and resets at 50. High pressure cutout opens at 600, resets at 450. Our coil temperature will lock out at 160 and reset at 145. The discharge sensor on the compressor will open at 250 degrees and reset at 235 degrees. And the one thing I want to point out when you look at the wiring diagram for this unit, it's actually pretty simple. But one of the things I want to point out is if you look at the top of the drawing, you'll see the HPCO and the LPCO. This is wired back to one circuit on the unit. So in our early systems of this, the systems we'll be introducing at first, the high pressure cutout and the low pressure cutout, either one of those trips will show a high pressure cutout because they're wired in series with each other. Sometime in the near future, that will be separated on the control board, and you'll see a separate fault code for HPCO for LPCO. But at the very beginning, this introductory product will have a high pressure cutout and a low pressure cutout wired in series. You're going to have to find out which one of it actually caused the fault. Let me just jump into the Q&A for a second, and we'll move on. Why do we why do we not connect Y2 at the air handler when BK is being used? Because the thermostat on the indoor unit, when you're using BK, the 824, the 724 thermostat knows that it's a Y2 call and will change the fan speed through BK. So when you're doing a thermostat like a Acon 724 or an Acon 824, it'll actually tell the control through the BK wiring. It changes the DC voltage going to the indoor unit to tell it to change fan speeds. Also, the defrost mode, also the X from outside, also does not have to be wired with a 724 or 824 stat. It knows when it goes into defrost and will energize the supplemental heat for that. All right. So remember, I mentioned on the control that the unit has a 7-segment display. That 7-segment display will actually help you decide what mode of operation that unit is running in, even if it's in startup mode, right? Because this doesn't come on and run at full capacity or even our Y1 70% capacity call immediately. It actually starts up with a slow RPM, and I'll show you here. It'll actually run to start to lube that system and get oil returned back to that compressor. So startup mode for the first 60 seconds, that display will actually show a 1-0. That 7-segment display will show a 1-0 to tell you that it's in startup mode for the first 60 seconds. After that 60 seconds, it's going to go to a 2-0, which is telling you that it's actually running at Y1 or 70% of that compressor speed. If you had a Y2 call, it will then show you a 3-0 to show you that that compressor is actually running at 100% capacity. So this is kind of a description from the service facts in the installer's guide talking about that 7-segment display. So if you look at the menu on the left, it's telling you what the value number is, and if it's the first or second digit, what it means. So again, standby, you'll see a 0, 0 with that first one. The 0-0 will tell you that the unit's in standby mode, meaning it doesn't have a call for any kind of compressor speed. 1-0 will tell you that it's in startup. 2-0 means it's in low speed operation. 3-0 means it's in high speed operation. Boost speed is really what's designed for lower ambient temperatures for heat pump, or if you're in a defrost mode to help it defrost that coil even faster. If you've had a fault or a failure on something where one of the sensors went out of range, it'll go to a 5-0. That's telling you it's in a limp mode and that it's running in a protective mode to protect the compressor. It's running at a fixed compressor speed so that we know that that compressor is running at a good wattage and getting good oil return. And anyhow, then you'll see the details of the other ones. And then if you look at the screen on the right, if that first value is an F followed by a number or a letter, that is telling you a fault code on that system, and it's helping you kind of lead towards the direction of where that fault may be. There is a test button on the MOC. So the MOC is really, that is where the compressor is being told what speed to run. The AOC board on the top, where our 24-volt connection is, that AOC board is where it takes all of the load values and tells the MOC what compressor speed it wants it to run. So if you want to test the MOC board, there's actually a button to put it into test mode, and it'll actually run a self-test for you and tell you where some of those faults may be if the MOC or the compressor is failing. And you can see that sticker kind of in the middle to the right, the tall, thin sticker with the 1, 2, 3 on it. That's the fault codes it'll give you depending on what it's diagnosing through that MOC board. The AOC board, really what we want to make sure is that our voltages are correct out of the AOC board and that our sensor readings are also correct. Our data sheets will show you that the voltage for it after it goes through the sensor or the ohm reading of that sensor. So fairly easy to diagnose if you're used to electronic sensors. Now let's talk about the operation of the unit. So operation of this unit, when you have a Y1 call, this unit will operate at 70% compressor speed. If you have a Y2 call, this compressor will run at 100% of its capacity. Now, it's being advertised or marketed as a multi-speed unit. Let me explain what that multi-speed is. For us, for American Standard and the 17 SEER unit, when I have a Y1 call and I have that 70% compressor speed, the only thing it's monitoring at that point after it gets its Y1 call is the outdoor ambient sensor. The AOC board, as we saw when we took our little tour of it, it has a plug for an ambient sensor. There's a sensor out in the airstream outside. When it sees that I'm in a mild condition, so if I'm in cooling mode, and let's say it's 55 or 60 degrees outside, but I do have a call for cooling, it's actually going to lower that compressor speed by a couple percent. And when I say by a couple percent, that sounds like a gray answer. That information is proprietary to American Standard, and they're not sharing it at this time. But what's going to happen is when it sees that it's mild outside, it's going to reduce that compressor speed by a couple percent. Only a couple percent. And what it's going to do is run at a smaller capacity during that mild temperatures outside. Now, let's say you have a Y1 call and it's actually hot outside. We're in the middle of July and August. It's 95 or 105 degrees, depending on where you live. It's going to increase that 70% by a couple percent. So now it's going to bump up the compressor by a couple percentage points to make up for that additional load outside to try to see if it'll satisfy it at Y1 at that point. Now let's talk about it in heat pump mode. The idea is the same. If it's mild outside and I'm running in first stage of heat pump mode, I am going to decrease that compressor speed by a couple percent. In the same essence, if it's super cold outside, I'm going to increase my compressor speed on that Y1 call by a couple percent and try to satisfy it there. Some of our competitors are actually changing that compressor speed by suction pressure. We are not. We are changing our compressor speed based off of the outdoor ambient. Now, let's get back to the screen here that's at hand. And this is one that's talking about a termination for heat pumps. So factory heat pump coil temperature termination is 50 degrees. Typically for American Standard, it's 47, but this particular unit is 50 degrees, roughly the same. Now, if you cut that jumper wire at the top because you live in an area that's got a high frost or high moisture content, and you need a longer termination or longer run time for that heat pump to defrost, if you jump that coil temperature now goes to 65 degrees. Charging the unit is very similar to charging a single stage unit today. You want to make sure that you're in a Y2 call, right? You can actually look at the control board on that condenser, see the 30 on the board. That's going to tell you that I've got a Y2 call, and then I'm setting it to my subcooling, just like we've always done in the past, okay? Now, if you've got a super long line set, there are adders that you're going to need to add for that longer line set, and that's no different than any of our other product. If you're doing link systems or if you're doing even a single stage 14 SEER, if you look in the installation guide and you've got a long line set, there may be cases that you're going to have to add to that subcooling number, and that's what it's displaying to you here. So when you look at the 17 SEER unit kind of unpackaged, it's going to look very standard to our old 17 SEER link system. Now, again, that 17 SEER link system is gone. They didn't reintroduce us to the new refrigerant. But when you look at the panel to the right-hand side, you can see the big aluminum structure. That is our MOC, or that's the portion of the board that tells the compressor to change speeds. Basically, what it's doing is taking your line voltage to a 230 volt single phase AC voltage and turning that into a 3-phase DC voltage and changing the hertz to that compressor to change that compressor speed. The little circuit board on the top, that is the AOC board. That's kind of the thinking board. That's where all the engineers sit to decide what that compressor speed is. So you've got the AOC on the top. the MOC, which is the other 2/3 of it underneath. Now, again, we're going to offer that as a warranty part. So if you have one of them fail, we would replace both of them right now. Eventually, American Standard will do those boards independently, but for now, they're doing it as one component. If you look at the TXV on the heat pump unit here, you can see that's a standard TXV. It is non-adjustable. The picture shows an adjustable one, but this is during lab testing. But the one that you're going to get is non-adjustable. It's a regular mechanical TXV on the outdoor unit. And the switchover valve is a latching switchover valve. So that will have a pulse of voltage that moves the valve over, and then that voltage goes away. And again, we talked about the wiring diagram. It's actually pretty simple. It's probably halfway between what an inverter one is and a regular 24-volt system. But these are going to be standard sensors, standard high pressure switch and low pressure switch, stuff that you're used to in the past. It goes into our demand defrost. Really, the demand defrost works similarly to as it does on our single stage or in our inverter style products. So if you're used to heat pump defrost operation, the thinking and logic of this board is exactly the same, except for your cutout temperatures, right? Because our regular boards do 47 degrees and this one does 50. Now, I'm a huge advocate of fieldtechhelp.com. This is a website from American Standard and /Train. It has 250 to 300 tech support videos on it that you do not need a login for. You can also access these videos 24 hours a day, 7 days a week from your smart device, your phone or your tablet. If you just go directly to fieldtechhelp.com, you will find 250 to 300 tech support videos that are roughly 3 minutes to 7 minutes long, helping you diagnose it. And let me tell you, I was on the phone for nearly 10 years with Shearer Supply, taking your tech support calls. 70% of the calls that we get are answered on fieldtechhelp.com. Again, you don't need a login to see the tech support videos. If the video says play, no login is required. And one of the videos that's on there is helping you diagnose the 17 SEER multi-speed unit. It's going to talk about that 7-segment display and the different numbers associated with it and help you do it. So let's say it's a few weeks before you install one. It doesn't seem to be starting up right, or you don't recognize the numbers. You can play this video sitting right next to the condenser, and it'll walk you through all that information. The warranty process for the drive is the same as it is for the communicating systems. This is the only component from American Standard residentially that you have to have an authorization from tech support to replace. If you walk into the counter with a drive and just drop it on the counter and ask for a new one, you're going to end up buying the new drive. You will need an authorization from the field FSRs or the tech support team. And if we're not available for some reason, the sticker on the inside of the condenser is a number you can reach somebody at the factory. So you will need this authorization number to process the warranty of a drive. The compressor doesn't need it, not any other component needs, just the drive. Let me jump into the Q&A, but I am done with the presentation. That went way quicker than I thought, but I'll be on for a while to answer questions. So let's jump in and see where we are. You said that this can be connected to a link communicating. No, Donnie, I did not. If I said that, I did not mean that. This can be installed to a piece of equipment that is link approved as well. So the S8 V2 furnace and the 5TAM-X and the 5TEMC air handlers are all link product, but they are also 24-volt systems. So you're going to be wiring this system up in the 24-volt mode. This is not link approved. This will not wire in with a link system. How do you suggest explaining that this is a 6-stage system to a customer? That's a great question, Cody. That may be a better question for your territory manager. What I'm going to tell you is this system's really designed to be a 2-stage unit with a slight fluctuation of outdoor temperature. Now, American Standard's going to market anywhere from a 4 to a 6-stage unit, depending on the size. But I can tell you that way it really truly operates is more of a 2-stage product. So you're going to have to pick that verbiage yourself. How do you force a Y2 call? You can just jumper Y1 to Y2, and that'll force it into a Y2 call. What does AOC and MOC stand for? Honestly, I couldn't tell you. It has something to do with the computer boards on it. AOC is the smaller board. MOC is the larger board. How long does Y1 run until Y2? That decision is made by your thermostat. So whatever thermostat you're using or utilizing, that Y1, Y2 call will be determined by your thermostat. 4 wires required for AC unit? Yes, that's correct. So well, 3, I guess, right? You're going to need a red, a common, and your Y. Well, Y1 and Y2 if you want to do 2-stage. But if you wanted to bring stages 1 and 2 together, you can do it as a 3. But in your question, Rich, if you're doing Y1 and Y2, yes, 4 would be required. Does the MOC have to be sized to the motor? Well, I mean, it's sized from the factory, but we have one MOC that does every unit. So there's one replacement at this time. With our leak detectors, will we be able to pick up the new refrigerant? That depends on the leak detector that you have, Randy. Either it's been approved for the new refrigerant or it's not, but that's dependent on the unit you bought. How do you diagnose the mitigation sensor on the coil? Either it works or it doesn't work. The fault codes on the mitigation board will actually tell you if the sensor is being read or not. It is a communicating sensor. So right now, the only way to diagnose the sensor is either it's communicating or it's not. In that step of service, they have you ohm out the wire trace, from the board to the unit, make sure there's nothing wrong with your wire trace. And if it's fine, then you would replace the sensor. How do you do? Can you go over the indoor and outdoor temperature numbers for charging? So charging in cooling mode, to set it by subcooling, the indoor temperature has to be between 70 and 80 degrees. So, right, the normal operating temperature a homeowner would have it. And then the outdoor temperature would have to be above 55 degrees outside and below 120. Does the line set need to be replaced on changeouts? No. If your line set is the right size and you already using a good flushing method, even if that's RX11 or whatever flushing agent you're using, if you're using it correctly, you can still use that today. Also, this is not zone system compatible. You can use zoning on this, but you would be using aftermarket zoning. So EWC, Honeywell, something like that. American Standard CL2, our 1050 zoning, they are not recommending it for the system. You would have to use Honeywell, EWC, or whatever a secondary source you're using. What zoning system do you use with this? Again, you're just going to use EWC or Honeywell or whatever zoning other brand you're using. Can we use the 1050 in the relay panel? Yes, you can. You can use the 1050 in the relay panel. You're going to wire it in with the BK, and the functionality will be a 2-stage unit at that point. Doesn't have enough low voltage wires for 824 or 724. Yes, you can use the 1050 in the relay panel, and you would use it in a 2-stage operation. Charge calculation chart shows unit comes with enough charge for a 10-foot of line set instead of 15. Honestly, Alan, I didn't read that, so I couldn't give you an answer. But yes, if the installation guide said 10 foot, then that's what it is. Yes, sir. So with the new condensers, will they all be inverters for gas furnaces? The only condenser that'll have an inverter on it will be this 17 SEER. Our 14 and 15 SEER are regular 24-volt mechanical systems. So this is the only one for 24-volt inverter. John, you're welcome. Thank you, sir. But are we out of parameter of the unit running? How to get the freon in the system? So John's asking if I'm out of those operating parameters, how do I charge the system? John, you would use the weigh-in method, and that's actually the same thing we recommend for even our single-stage air conditioners. If you're outside of that 55 to 120 or 70 to 80 indoor, you should be weighing it in already and coming back to convert it. That's been part of our installation process for a while now. With the concern of leaks, how they fix the line set from going under the outdoor coil. The outdoor coil design, as far as I know, is not going to change. Where that tubing passes underneath the coil in the outdoor condenser, American Standard has no interest in changing that. I know it's probably not what you want to hear. They feel as part of your maintenance process to that home, you're making sure that that coil is off of that tubing as it shifts and settles over time of operation. American Standard says that's their most efficient way of doing it. They are not looking at changing that. I'll stay online for a couple more minutes. Again, this video will hopefully be up on YouTube sooner than later. If you missed part of it or you want to share it with somebody else, it will be available hopefully on YouTube sooner than later. And your territory manager should have a link to it when it does come out. What is the maximum high voltage outside? I believe American Standard goes to a plus or minus 10%. Look at the installation or the submittal will give you that exactly. But I have not heard of anything outside of that 10% for this unit. I like to push in on the contactors to first run. There's no contactor on this unit, John, so you're going to have a 24-volt call to the AOC board for it to run. Do we use recovery machine to get the Freon in the unit when it's too cold to run? I haven't heard of that process, so I'm not going to answer that. But weigh-in method, you may have to use a bottle warmer or whatever when it is that cold to do the weigh-in method. Thank you, Kyle. I appreciate it, sir. I'll stay on for a couple more minutes to see if anything pops in. If not, you guys have a great day. I appreciate you being partners of Shearer Supply and helping me feed my dogs and keep a roof over my head. Thank you. Cody asked if this boost is 102%. I have not seen any data to specifically what that boost number is. That boost number will depend on the ambient temperature. But at the moment, American Standard saying that those percentages above and below are proprietary and they're not sharing them as of yet. You might have answered this, but how would you pump the system down? You can actually have a Y call from your indoor unit and such a thing in, and you would have to separate the wire or pull your disconnect to turn it off. Can I add a transformer outside? I haven't seen that as an option from the factory yet. So Rich, if you try it, let us know how it works, brother, and I'll share it with everybody else. What about stop, leak, or die? American Standard does not approve stop, leak, or die in any of their systems. So please do not use it in this one as well. This may have been asked, but I missed it. But what are the systems going to be available? My understanding is they're starting to ship from the factory now. So we should hopefully see them in inventory in the next couple of weeks. Now, stuff is trickling in from the factory. But if you have a need for this, you definitely want to let your TM know so he can get an order in the system for you and have it held so we can fill that order as soon as possible. But the factory is starting to ship them now. Is pushing boost during defrost proprietary? Does it work with other brands? Well, the defrost is going to be called by the condenser. So it'll do it itself when it goes into that defrost mode. It's going to try for energy efficient reasons to get out of defrost as soon as possible. So it's going to energize the boost to get the ice off the coil. So it's just within the condenser that action happens. Nothing to do with the indoor at all. All right. I don't see anything else coming in. Thank you again, guys and gals, for being with me this morning, and have a blessed day. And thank you again for being our customers.